recording. Hello, YouTube. Let's get started with a new advent of code. So, the encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paperclips. Upon connection, the port outputs a series of numbers, your puzzle input. Okay, so that's nice. That's easy to parse. Like, parsing is the most annoying part of, or at least of this year's advent of code. I've never done it before. This is my first year. The data appears to be encrypted with the Exchange Masking Addition System, XMAS, which conveniently for you is an old cipher with an important weakness. XMAS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. Okay. The two numbers will have different values, and there might be more than one such pair. Okay. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of two of those numbers. So 26, it's fine because it's 1 plus 25, or other combinations. 49 is fine because it's 24 plus 25. 100 is not okay because you can't add two numbers 1 through 25 to get 100. Okay. 50 also is not valid because you could use 25 twice, but using the same number twice is not allowed. They have to be different. Okay. So let's suppose that the 26th number is 45. 26th number is 45. Okay. So the first number that you get after, and the first number, no longer an option, as it is more than 25 numbers ago, was 20. So you don't have 20 anymore. Right, and now you need to build 45. So now for the next number to be valid, there needs to be some pair of numbers among 1, 19 and 21, 25. So every number from 1 to 25 except 20, which is the one that we lost because it fell off the window. And among those, or 45 that add up to it. Oh, 45 becomes part of the window, right? Because you always use 25 numbers. So 26 will still be valid. Suppose that the 26th number is 45. So, okay, if it's 45, then first we have to check if 45 can be composed. Right, I think this is skipping a step. Because the 26th number would be the first number that we need to check for sure if it corresponds to the 25 before. Anyway, well, okay, we can easily see that it works out, I think. I'm not actually sure. Probably. Well, you can do like 21 plus 24, I guess. Yeah, okay, so 45, you can be sure that it does match. So now you have 45 in there. 26 is still a valid number because you can still use 1 and 25. 65 is not valid because you won't find two numbers that add to it. 64 and 66 would both be valid because they both are 19 plus 45 and 21 plus 45 respectively. Okay, here's a larger example which only considers the previous 5 numbers. And it has a preamble of length 5. So the first 5 don't need to follow any property, but from here they do. So 40. How do you do 40? 15 plus 25. How do you do 62? Using these 5. So 35, it's not an option anymore. Now you have 62. 62 can be done by 15 and 47, right? 15, yeah. Okay, so now 55 would be 40 plus 15. Okay, I'm not going to do all of them, but I think we get the gist. In the example, after the 5-number preamble, almost every number of this, almost every number is the sum of the 2 previous 5 numbers. The only number that does not follow this rule is 127. Okay. The first step of attacking the weakness of the XMAS data is to find the first number in the list after the preamble, which is not the sum of 2 of the 25 numbers before it. What is the first number that doesn't have this property? And this is the puzzle input. I mean, this doesn't seem particularly hard. I'm kind of tempted to go straight into the puzzle input and not even try with this. YOLO, I guess. I'm gonna try to stick with Sublime. Is my LSP dead? Oh, you know what? I think I restarted Sublime, so I might need to do LSP. Oh, there's also restart servers. Yeah, restart servers. So day 9, also new. What is this? XMAS day 9.txt. Here's my input. Const data equals embed file XMAS day 9. Please, Sublime. Yes. Okay. I don't know why sometimes it shows me the completion. I press tab and it doesn't catch it. And I'm missing a at embed file. Okay, we have our data now. Now we want. Holy shit! Some numbers are pretty big. Okay. Whoa. Okay, we want to read all the numbers, I guess. Well, no, we don't even need to do that. We can read that as we go. So var iterator is std.mem.tokenize. Want to tokenize data, and the delimiters are just a new line, nothing else. So we iterator, so for it.next, and wait, I'm wrong. This is not a for loop. This is a while loop. While we have a next that is not null, get a, I don't know, let's call it n. We call it n. Let's call it line for now. So what do we do with line? We parse it as a proper number. And to parse it as a proper number, we do, I guess, const n equals std.fmt.parseInt. In what type we parse this stuff? Are they negative numbers? No, right? No, everything is positive, of course. So, well, of course, at least it is for now. So usize is fine. The string is our line, and the radix is 10, base 10. Then we have our number. What do we do with it? We need to have a place where we store these numbers, because we need the 25 long window, right? So, oh, here's what we can do. You know what? Let's say that this is the general procedure where we also check the list. But before that, we have an initial procedure where we do 25 times. We grab the 25 elements of the preamble. So this is going to be a this is going to be a for, because here's what I'm going to do. I'm going to say that my window is an array of 25 sizes. I don't well, the proof for real. I don't initialize it. And for each element of the window, so for each call it slot, and I want a pointer to each slot because I want to change it. I don't want to read anything. I want to write to the slot. So we get a pointer to the slot, and we do slot dot star equals itnext dot question mark. So itnext can fail. Wait, no, wrong. Is parse int of this. So itnext can fail and return nothing because it fails to because there is no more tokens to produce. And here I'm asserting that what I get is an optional basically, and here I'm wrapping the optional, asserting that there's gonna be something in there. In debug and release safe modes, this produces a panic if this is not true. In release safe mode, this is gonna produce undefined behavior. So this is like how can I say? It's like an optimization. I'm saying I don't need to check that this is not null. I'm pretty sure it's not null, which in my case is gonna be because this is gonna run only on this input. So I don't care about making a robust application that works for a general use case. So we chuck in there 25 numbers, and we got our preamble field now. Oh god, how do we do the rotation stuff? Do we really move everything every single time? Oh god. No, we need to keep an index that tells us which is the oldest element, and we keep moving this index, which tells us which is gonna be the next element. Yeah, I'm also missing a try. Thank you. I think here. Also here. So we need to keep an index that keeps telling us which is the oldest element, so that it's the next one that we need to evict. So var oldest index is a usize. Starts at 0. We have the window, we fill it, and then every single time we extract a number, we parse it as a number, and then can we place it immediately in there? Let me think. No, we extract a new number, we check on the 25, and we place it in the oldest index. So at the end, I guess you could say that this is gonna be like this is the continuation expression of a while loop, where you do stuff basically at the end of the loop. It's like the I++ basically part of this construct. In here we're gonna do oldest index plus equals 1, almost, because it's not modulo what I want. So I guess I need you know what, I guess I need multiple lines. So I'm gonna do oldest index equals oldest index plus 1 modulo 25, which is the length of our preamble. And then, but before that, so this is the next step. Before that, we want to also set, I would like to set n, but I don't think, do I have access to n from here? That's interesting. You know what, I'm gonna leave just this expression in here, and oh, that's interesting. Okay, you know what, I won't try to be fancy in this case, because I need to do two things. I don't know if I have access to n from inside this block, and I could play around with the fair stuff, but then it makes everything harder to reason about. Let's think simple. So before I update the index, what I want to do is that I know window oldest index needs to become the new number, the one that I just extracted, because now it becomes part of the window. And then we increase the oldest, the counter. So that's fine. So this should be good. Now here we need to check the property. Check property. So how do we check the property? How do we check the property? We need to search, I guess, in the window two numbers that add to our own thing. So what we can do, I guess, is so we could be smart and try to keep them sorted. Awful idea. Maybe, but maybe it's necessary here. Maybe it ends up being that you start looping enough that sorting is worth it. Because if you do the naive search where you keep looping twice, you loop for one item and then you loop also for the second item, its quadratic complexity is big O of n squared. If you do the sorting, it becomes n log n. But I'll do optimizations when this thing forces me to do optimizations. If it doesn't force me, whatever, I'm not gonna do that. So let's do the naive loop. I guess it's for window x for window y. They have to be different. I think the numbers are already confirmed to be different, but so let me think about it. How would this work? So if I do this, I could start I plus 1. Would this work? So here's the idea. I know that I got this wrong. There was a bug in my implementation when I did something similar in, I think, the first day. So let me try to get this right this time. The X, let's call it like the top cursor, starts from the beginning. Y has to start from the second slot, like index 1, and scrolls until the end. Then the upper thing becomes the second item, and then Y becomes third item and then scrolls down. Yeah, that seems right. So if x plus y equals n, or actually, well, yeah, no, if it equals n, then we are good, but we found everything, so we break. I want to break not from the inner loop, we're done, like the search has been concluded. We want to break from the outer loop, so this is like outer, I'm just gonna give it a name. So we break from the outer loop, and we're done. And and that's okay, it means that this number checks out. But what if we, and actually, yeah, no, okay, that's fine. So we break from the outer loop. This stuff out down here needs to happen every single time. But if we fail to break from the outer loop, what happens? It means that we didn't find any match and we searched everything. So here, else branches attached to for loops in Zig mean that this is what if you didn't break. These are used for searches. So the idea is you break when your search succeeds and you do the else branch when your search fails. So in the else branch, we say, well, this is the bad number. So we do, I guess, print bad number, new line, and just n. Is that it? I think that's it. We need to report the number, right? Just to double check. Yeah, what's the first number that does not have this property? So that's it, I guess. No, micro stays there. The AOC, oops, AOC. Sig build day 09. Let's see programming errors. Okay, no programming errors immediately. Bad number, boom, this guy. Okay, let's do one sanity check. Can it be found in the list? Yes, okay. So we passed the basic sanity check. Let's see if it's okay. Right answer, yay. That wasn't particularly hard, I would say, right? I mean, I can see this becoming hard if you don't have these nice constructs, right? By the way, this block here, I just made it to show that this is the stuff that checks the property. Everything else is just for the iteration. It's nice, I can do it. Like this is cheating, I think. Like if you have, I don't know, stuff that doesn't allow you to break two labels, for loops that don't have an else case, you have to work a little bit more. And of course, like the chance of introducing errors increases. But I mean, this was easy. So let's hope we don't get murdered in part 2. So the final step in breaking the XMAS encryption relies on the valid number that you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. You need to find a set of at least 2 numbers. Oh shit, so now the numbers are not only 2, it's a set of numbers, of at least 2 numbers. Okay, so consider the above example, blah, 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 blah. What was the original number? 127. So these are the numbers that sum up to 127. Okay, in this list, adding up all the numbers from 15 to 40 produces the invalid number from step 1. Of course, the considered step for number in your actual list might be much longer. Okay. To find the encryption weakness, add together the smallest and largest number in this continuous range. So in this example, they are 15 and 47, which produces 62. So what is the encryption weakness in your XMAS encrypted list of numbers? Woo! Okay, so we got the number. I guess part 1. Okay, so we need to do part 2, right? Well, we got number, so no reason to compute it, I guess. Then what else? We know the number. Var bad num is this, actually const. So we have this bad number. Then what we want to do is, well, kind of the same here. We don't even want to fill the window. We just care. So we do the iterator thing. That's interesting because we need to have a more elastic approach to what we are doing. Earlier we had a 25 long window. Now our window needs to make space for more numbers as they come in, and then reset itself afterwards. When it's like blackjack basically. It's like blackjack where instead of going up to 21 you go here. So let's play blackjack, I guess. How do we do this? I could use an array list to have something that genuinely shrinks and widens, but you know what, let's do that. I was about to do something, my usual bad crap, but this time I want to try to be a good citizen. So let's first initiate this stuff before going into iteration. So we start with the med number up top. Yes. We need an arena locator. We need then a need an array list. So oops, we can do it ourselves, I guess. Var window is std array list. Our array list contains numbers, usize, and we init it with the arena.allocator. So we have a window. We have a window. Wait a second. Do we need a window? Yes, we want a window and we want the current total. Oh, wait a second. Okay. So, I mean, in the beginning, it's easy. We have to make a gigantic number, right? So we start saying, okay, 42, well, it's not enough, so we need more. 27, 23, 19, okay. We had a bunch, and at one point, we go over that number. Like here, we went over. So you have to throw away something. What do you throw away? You throw away the oldest number. Are you still gonna be over? You might still be over in that case. So what do? You need to throw away more from the tail. More from the tail until you go under again. Or maybe you catch it at that point. That would be nice. Now you go under, and now you need to add something from the tip. Okay, that's our strategy basically. We need to grow on one end and shrink from the other end. Grow as long as we're under, shrink from the tail when we go over. I'm kind of tempted to parse everything immediately into an array list, get a slice out of it, and then just play with the slice. So I won't use the append, push, pop, remove stuff from an array list. I think it's awful. Here's what I'm gonna do. I'm gonna use this array list just to parse, although, you know what? We know how big this stuff is. It's 1000 elements, so through all this stuff. Var numbers is an array of 1000 usize. We tokenize everything into their numbers. Expected semicolon found var. Sorry. Okay, so we tokenize everything in there. Yep. After we tokenize every single number in there, then we start. So var tail equals tail usize equals 0. Var head usize equals 0. Var count, I guess let's call it running count. It's a usize, it's a Susie. Equals 0. And now while running count is different than bad num, what do we do? Well, if running count is lower than bednum, we need to grow from the head. So we need to do head plus equals 1, and running count needs to be increased. Running count plus equals numbers at head. So we add new head, the new element from below, growing downwards that we added in. Else, and we know that else is gonna be running count is bigger than bednum, because if it was equal, we would when it gets equal, we break outside of the while loop. Else, here we say we say tail plus equals 1. Hey, Sumaswag, thank you for the follow. Welcome to the stream. So we push down the tail and we remove from the running count what we had there before. So actually what must be done before. So running count minus equals numbers tail. Is this always going to be positive? I think yes, but you know what? We are going to do a build release. So Zig is going to tell us if we overflow, underflow, or whatever flow. Okay, so this is it. And we get here at the end. Now, if this condition never gets gets met, like if we never meet this condition, we're gonna at one point go out of bounds, which is another thing that Zig is gonna warn us about. But what I want to do then is, I guess, print the running count, and then we check visually that the number has to be kind of the same. And then I do the second part, or is it cooler if I get everything right first try? I'm kind of tempted to try everything first try. This is going so well. So what you need to do is add the smallest and largest. So smallest and largest. So var min usize equals min equals bednum, and var max usize Susie equals 0. We want to give opposite limit values as default values, because then we can do while, well, not while, but for numbers between tail and head. So for these numbers, I think head should start at 1 now that I think about it, because it's not included. Like the rightmost thing is not included. No, I think it's fine. So head starts at 0, and I think here I should do head plus 1, I guess. That makes sure that head is included. Okay, so this makes the math match. So for every number in there, what we want is, if n is lower than min, then min equals n. If n bigger than max, then max equals n. And that's pretty much it. You know what? Let's be good people. Let's put an else in here. So it's like things only happen if this is super ugly. Climb. Excuse me? Since when? That's disappointing. Actually, this goes inside. Go inside. Okay. Now we found min and max. And what was the story? I had to get the smallest and largest. So I guess print. So let's check the condition and let's print that the condition is met. And then let's do min or whatever, and then let's do the result. So what we want to print is running count actually equal to bednum, just to make sure that there wasn't any horrible problem with this condition and the logic in this while loop. And then we want to do, so we expect a true to be printed there, and then just give me min plus max, and that's it. Programming errors. Okay, integer overflow, interesting. Okay, so here's the problem. I got an integer overflow, but the stack trace is bogus because stack traces are broken on the Apple M1 architecture. So I can't use those. So charb browser has an import with two different formulations of my example on Reddit. Oh, okay, I'll check them out later, thank you. So why are we overflowing? And also it's integer overflow? Is really usize not enough for this stuff? I need to know where I'm overflowing. Am I overflowing here? So print while loop completed. It's in the while loop that we overflow. Okay. Is this something that I do multiple times? Wait a second. Is this like an initial condition that is a bit messed up because I mean the corner case where head and tail are the same index? So let me run like the first couple of iterations mentally. Running count is definitely different than bednum in the beginning, no doubt there. Then is running count more than bednum? Answer absolutely yes. Head increases by 1 and we add to running count numbers head. Yes. And we keep doing this for a while. Are we really like overflowing? Oh, I wish I really would get the proper line or where we overflow. That's disappointing. You know what I could do? I can do, I think I can do /d target equals x86 64. Let's see if this works. 64 macOS. I don't know. Muscle. Able to build muscle CRT file. CLI file STDR. Unexpected token insertion directive. I don't know. MacOS. Well, let's not specify the ABI because I don't know what to put there. Symbol not found. Okay, so I can't cross compile from this machine. That's the problem of living on the edge with the architecture. I guess I need to find where I'm overflowing. Is this really a matter of making this number bigger? of weird though. Like this number is big, but it's not that big. No, it makes no sense. Like unsigned 64-bit can contain so much, and we should never go above this number. So what's the deal here? Why are we never subtracting stuff as we need, as we should? We don't get here. Then let's print looping and then print the number. Oh, without this cross completion stuff. Could it be that I just encounter a gigantic number afterwards and that's it? You know what? I guess I want the head index. Give me the head index so I can see what you're gonna try to add immediately after. Head. So we got this pretty big boy. Oh, and wait. Let's also do this. Here we're gonna print a plus and then a new line. We need nothing. And here we're gonna print a minus. So that you tell me what you were trying to do next. Okay, so I think we underflow more than overflow. So we have this number here. Let's see, position 545, line 545. That's not that big. That's 78 millions. And we got 155 millions. What? Why do we fail in a subtraction that looks perfectly reasonable? That's kind of weird. So show me running count again, minus numbers and tail. Oh wait, here I'm always printing head. I'm not printing tail. Right, head, tail. I also want tail. Well, you know what? It doesn't. I should print the right thing in the right position. So here I should print head, and here I should print tail. Yeah, that makes much more sense. I'm still gonna leave this extra equation here so I can monitor a bit better what happens with subtraction. So here I'm trying to do, yeah, it goes negative. So our number goes negative. Ooh, how do we do with this? I guess it's, if we just make this signed, we are done. Is this it? Oh, incompatible types, I size and U size. Right. Oh god, we go back to this problem. Okay. Wait a second. No, that's a bug. How the hell can it go negative? How is this possible that this thing goes negative? There is definitely something wrong. Okay, there is something wrong in my algorithm. There is definitely something wrong in my algorithm, and I think tail overtakes head at one point, which explains why we're going negative. How is it possible that tail overtakes head? Maybe we should give it better starting conditions. So like we should start with a window where we have tail being 0, head being 1. And the starting count is numbers 0. It will give it a better start, maybe. No, we still have this problem where head overtakes tail. I'm clearly missing something here. How can it be that tail... Okay, no, it's definitely possible. Okay, let's say that we have... Okay. It tells you integer overflow in running count. Oh yeah, thank you, Flounder. I found that too by debugging. So by looping, my prints tell me that everything fails here while trying to subtract. And in particular, at one point, my accumulator, the running count, has this value. And we try to subtract another pretty chunky value that brings it to the negative numbers. Now, I'm trying to understand where is the hole in my logic, and I think I found it. Like, let's say that we have 100, 1, 1. Or no, let's do 100, I don't know, 10, 10. And our target value is 111. So, and then there's, I don't know, 5, 5, 5, 5, 5. So, first we select 100. Is it lower? Yes. So we need to add more. Now it's 110. Is it lower? Yes. We need to add more. Is it lower? No, it's higher. It's 120. Okay. It's 120. Then we need to get rid of the 100. So we subtract that and we get to 20. And then we ask the question again. So how is it possible that it's so weird. I have a running counter which is a sum of numbers n1, n2, n3 ... And there is no way that removing one number that was added beforehand makes me do this, makes me go negative. There is no way. Subtracting is always gonna should always keep me positive. So why am I subtracting random crap like that? Also, is this minus this? Are we in a garbage situation of some kind? So, out of curiosity. Okay. So this seems right. So we were below, here we got above. After this subtraction, we are still above. Then we are trying to subtract this. But why is tail... How is it possible? Like, how is tail so far in it's position 546. Well, it's 545 if you index by 0. So this is correct. But how can this be here? Okay, so tail is going forward way too much. How? Why? Why is tail... Also, the fact that tail goes overhead is another crazy thing. What did they get wrong? Increase head, and we add the new head to the count. We remove the old tail, and then we increase it by 1. I think that the problem could occur when you only have one number in your set that is bigger than the bad num. Only one number that is bigger than the bad num. I think you might be right. This seems to be a position where this can happen. When you only have one number that is bigger than the bad num. But even if in that case, wouldn't I just try to delete it? I would try to delete it, no? Unless, I think you're right. Although, I should get to 0. If I have one number inside my slice, and I'm assuming that the accumulator always reflects that correctly, I delete that item from my slice. The accumulator goes back to 0, which corresponds to the empty slice. So I'm thinking, I don't think this is possible. Or I mean, maybe it's possible in my buggy code, but conceptually, I don't think that's a proper possibility. And I think the fact that, but I think that you are probably right, generally speaking, because my tail is jumping over the head, and that's definitely not correct. My tail at worst should be on par with the head. How is it possible that we jump over the head? I think there's something wrong with my conditions. Although I'm updating running count every single time. What if I increase head after doing the add? Now, I have no idea if this makes sense. Enough with this target stuff, please. I have no idea if that makes sense. I'm just trying stuff out. Oh, now it completes. Okay, why is this wrong? So I was adding the wrong thing all along. So now everything makes sense. And I bet you that this freaking number is correct. That's the right answer. So why was this stupid? So now that I made the change, honestly, I made the change just to try it out, because I knew there was something wrong in this ballpark, but I didn't know precisely what it was. But what I think was happening, like if you think about it, there was something wrong right away. We were, for example, not adding the first number. Like when we start, we have nothing inside, right? We're an empty slice and we don't add anything to the count. Oh, you know what? If you remember at that point, I was off by 2. No, okay. Could it be that I was off by 42? And the problem was precisely that these ordering error prevented me from adding 42, and that was the entire problem. If the two numbers were off by 42, that would be so funny. Actually, let me put everything back. So let me do the error. Are these numbers off by 42? God damn it. There you go. Here's the bug. That's all. That's it. Basically, by increasing head before, I was not adding the first number. It kind of wasn't off by one error here, but it doesn't matter much. Like, yeah, we don't care about this tracking too much. I don't know. Maybe it would have messed up also the final result. But yeah, the cause of the overflow, the reason why the invariant that we expected to always be true, meaning like this set stuff here, like if you add a bunch of items to a set and you sum them up and then you take one away, you can never go negative, because at worst you go to 0 because there is no other numbers, so it cannot go negative. And this was happening here because I was doing stupid stuff with the index. So, and yeah, turns out that the point where this thing was tested was when I should have gone back to 0. I mean, now we found. I mean, kind of shameful. First part was easy. Second part, I was the one messing around. But hey, nice with this sliding window. Yeah, I guess like my nemesis was this. I erroneously increased the counter of head before doing the count, and this kind of killed my mood. Honestly, I have no idea how to do it without sliding window. Like when I was thinking about it, without sliding window, I don't know, it's like, what do you do? Oh, I know what you do. I guess you keep adding, and when you pass, you increase the tail by 1, and then you try adding it, you start again. Just nice more for loops, okay. More for loops, more layers. It's always the solution in computer science and in software engineering, I guess. I don't know. It's not bad. I mean, like the first part, by the way, with Zig is so nice. Like it's amazing. Checking the property. You want to like. By the way, here I was doing the naive thing. I wasn't sorting or anything. I was just nesting two loops, and then when you find stuff, you break the outer loop. The else branch tells you the one time where you didn't find anything that matches, and that's your solution. Without this stuff, not as nice. So this was on point. This also is not bad. I mean, at the end of the day, it's my fault. But yeah, so I don't even want this print stuff. Okay, not bad. Okay, there was a comment earlier about oh, was there any more activity in the thread? Can I put this as a tab in there, please? Please, Safari. I know what I can do. I can do virtual windows. Oh no, that was an awful idea, because this should be here. Okay. Where is it? Okay, here. Okay, Mac, not nice, not good. Disappointed. Really disappointed by this window management stuff. Cool, thanks. Definitely looks very promising as a C replacement, also to work with together with Go. Yeah, I'm curious if there are things similar to pprof for Go. for finding out where to improve your code in Z. It's very nice to actually have profiling data when you do it to speed up coding. Go, I think that somebody that actually knows how to do proper syntax programming should reply to this person. I mean, perf, I think it's like not something go invented, so you should expect normal binaries to have this stuff. I guess, yeah, trace is the lazy answer, but there's also, is it perf? Maybe it's actually pprof, and okay, pprof is the Go one. What's the normal one? Is it perf? Oh my n. Performance analysis tools for Linux. It's like there's the normal one that does performance on general executables. Like you don't need something integrated with the. Oh, perf is the normal one. Thank you. Yeah. So somebody should tell this person that Google didn't invent profiling tools. I mean, it's nice that they provide them for the language, absolutely. But you should expect native executables without runtime or stuff to actually do what they need to do. For TinyGo, I think you need to just compile it from source. Yeah, but it needs LLVM compiled for source, which only demands Go and LLVM. The repository comes with a working version of LLVM. That said, Go might be suffering here from a compatibility layer because of the very recent launch of M1. It's actually the opposite. Go works. The LLVM build script inside TinyGo doesn't work. And I don't know, in any case. The first version finally hits about the TinyGo speed on my Chromebook, which makes sense because both use LLVM for the final result as far as I know. I just checked it again and it hits sub 2 seconds on my VPS now, which is much faster than it used to be. While your first version is close to 1 second, so it's actually a bit faster here, but not by much. Yeah, I got lazy trying to make to compile LLVM. So I gave up. Go actually works fine. About this, you can make it even faster if you avoid allocations altogether and replace replace the slice with an array of 2 elements. 2 I64. Clearly not a robust solution, but you can generalize it as prepare on the stack an array, a buffer big enough for my solutions, and have pass a pointer. You know what? Why am I describing this? Let's just write it down. So much easier. We had it in here. Did I close it? Oh yeah, I closed it. Did I ever save it? Yes, I did because I compiled it. So cd versus go script zig. So here's what we do. Instead of an allocator, we pass in a buffer. What is buffer? Buffer is a slice of I64 we pass in a pointer to the buffer. Here we do var I size equal to 0. Every time we put something inside S, I plus equals 1. And then at the end, we return path from the beginning up until I. Return bug. What do you mean? What happens? No, this should be fine, no? This returns a slice. This is not a problem. Oh, wait, okay, let's see what people are saying. I missed some messages. Oh, how do you scroll up in this thing? Oh god. Well, I have chat over here too. So what post out of code per shenanigans are you up to today? Let's see. I'll say. Oh, there's also a bunch of stuff from iFreund. For loops, you could use this mean. What post out of code per shenanigans are you up to today? Tracy's lazy answer. Perfect. Okay, so sorry, I read all this stuff. Yeah, LLVM CLang LLD takes like 10 minutes to build. It's horrible. I think it takes even more. Oh no, right, this is not the full LLVM suite, but I think Jacob was telling me that it takes 20 minutes to build what I needed to build Zig. And I don't know, it's just the reason why I'm here programming in Zig and learning Zig and stuff with Zig is because I have zero intention of learning how the C garbage stuff works. I don't want to learn make files. I don't want to learn C compilers. I don't want to learn C header files stuff. Like, this is janky as hell. And I don't need that in my life. So that's why I'm here, because I don't mind learning certain things. I don't mind learning how the computer works, writing efficient code. It's just that you take away Zig and like you're in a land of radioactive garbage, and I don't want to put my feet like in a puddle of radioactive makefile system dependency stuff that on macOS it's even more jankier than on Linux. So no thank you. Oh, page up and page down works. Oh yeah, they do. Thank you. You know what? I didn't even try because I got used to the idea that all these command line, all these terminal applications have super wonky binds. I was expecting like Control Alt Shift semicolon to go up, something like this. So thank you. Oh, return bug is the typo that you made. Okay. So okay, let's check if this compiles. I'm writing in chat. Zig build. This is a Zig build. Zig build XZ. And also, my own nickname is completely broken, so we need to fix that. Why am I not printing my own nickname? Oh, you know what? I might not be listening to the right signals. I might have removed. Okay. Wait. Let's go. Later we go to Perl. Okay, use an identifier S. Yes, you're right. This is buff. Is this faster? Oh, you know what makes it faster? I know what makes it faster. Release fast. Yeah, at the end of the day, probably this technique doesn't even change much. Not really an improvement. So at the end of the day, this is more, I guess, idiomatic. I don't know. no allocations, nicer, better, no allocations, but it doesn't really improve performance. Oh yeah, I remember what improved performance was using unsigned stuff. If you use unsigned stuff, it's more performant, but then you have undefined behavior somewhere. So yeah, I think it fluctuates. Like even if I bring it back, it's probably gonna be in line with what we have now, more or less. Let me see. Also, another thing that that it's not properly explored is the fact that there is a catch unreachable, and I don't know if it should be a catch unreachable. So yeah, I think the numbers are a bit higher now. I don't know. There's something happening in the background. So, but they're still kind of in line. 716 mean range. Okay, this is a bit worse. Wow. I think these have like there's no reasonable p-value in like the confidence interval is gigantic or gigantic. It's bigger than the delta between these changes. I think it's fine. At the end of the day, so it turns out that I don't have a good reply there to make it faster. I don't have anything to say actually. I mean, a reply would have been worth it if I had if I could provide any other info on how to make it even faster. But like these other changes don't change much, which again it makes sense. Like it's two numbers, so you allocate nothing. Like you allocate once, which becomes basically part of the startup time, and everything is here. Like what really decides stuff is this, how efficient this can be. And the moment where the moment where everything got really fast is when it was wrong. Okay, so this is it. Oh, there was an NIM version that somebody posted earlier, right? Let's see. Two NILAM solutions based on this Reddit thread. So nice and compact, but allocates a sequence. Okay, returns a hash set int. I think also we are not being so, we're not even returning a hash set. Yeah, I know that the Python version was using a set, but the other versions were just using slices. Like the Go version was using slices. So this is also more advanced than what we are doing. Slightly more verbose, but no allocation of a sequence required. Okay. But yeah, but this has to allocate. At least here you have to, no, it's not just that. I think you have to allocate here and here. If you are initializing the set from inside the function, it means that this has to live on the heap. Or I know, oh no, wait, it doesn't have to. Maybe if you have like result location stuff, maybe it doesn't have to allocate, but this allocates for sure. But I mean, it's fine. It's a hash set. Like if I were to do the same thing with Zig, I would either have to allocate on the heap or like do weird shenanigans with buffers and stuff. So at the end of the day, we're there. The difference is that in Zig, everything, all this stuff is always up front in front of the programmer. Like every time you allocate memory, you know you're doing this. You can see it in the code that there's stuff using allocators and stuff. And I think it's nice occasionally to get to a situation where boop, you get rid of allocations. Yes, this is kind of janky. Like this breaks. If you have more than 100 solution, it breaks. So this is not equivalent to what it was there before. But hey, I think it's kind of fun. And And there are other situations where this transformation, like changing from a location to a fixed number of things, like a max value that you know it's enough, that works too. That said, also array list also pretty good for that. So there's a bunch of interesting options that you can have. It's more verbose though in any case. Like if you compare it to NIM in terms of like how can I say, terseness, ease of programming, I guess. I think NIM wins easily. NIM is I mean, you saw the code, right? Like the one-liner was pretty sweet, I guess. I mean, I'm not super used to NIM syntax, so to me this looks slightly too much condensed, but this is my untrained eye. I can think of a similar Python version, right, where you're using a list comprehension, and I would love that because you don't have to type much, because it's kind of cute. But then, so for example, here you know that you have to allocate a sequence, and here you don't, and it's not super obvious, not as obvious as it is in Zig. Okay, so wait, why am I still recording? I should have said goodbye to YouTube a while ago. So you know what? I'm gonna cut the recording now.